Right, so now I'm going to continue with our hammock idea and talking about using it for interplanetary spaceflight. So the idea is that you would have people, if you have people who are well adjusted to very fast spin rates, then they could go out they could be the first people to go out to do interplanetary spaceflights. And in there, they just have a hammock which would just be 2 meters diameter inside their spacecraft. But I think you shouldn't do that straight away, because you would need to have experience to see that this actually works. You need to know for sure, for instance, that you can actually survive several years, and you might get very promising results straight away. You would need to know for sure that this does actually work. But there's lots of aspects to an interplanetary spaceflight. It's amazingly complex. And to think that just because we've gone up the ISS and spent a few months in the ISS, and some people have managed to go for a year or so getting rather ill, it doesn't mean that we're ready to go into interplanetary spaceflight yet. For one thing, the ISS then have continuous resupply from the Earth. So you're sending tons of stuff up there, and then tons of stuff going as waste into the atmosphere and burning up in the atmosphere. So for an interplanetary spaceflight, to simulate it properly, then I think we should actually do an actual practical interplanetary spaceflight but closer to Earth. And it turns out that we have a really nice place where we could do that. And so that would be the far side of the Moon, but we would start off on the near side of the Moon. And I'll explain how that works. Actually not on the surface of the Moon. It's the Lagrange points, the L1 and the L2 Lagrange points. So the L1 point, that's between the Moon and the Earth. It's a sort of point of balance in gravity. It's a little bit like geostationary orbit, where you stay above a particular orientation on the Earth. But in this case, you remain at this particular orientation relative to the Moon. And so as the Moon is going around once a month, you also go around once a month. And if there's a near side and there's a far side, where it's due to the balance of the Earth's gravity and the Moon's gravity, both of those take into play, and you find these points of balance where in a rotating frame, then there's no forces pulling you in any direction, and you can just balance in between the Moon and the Earth. And there's another point of balance beyond the Moon. And they're equally distant from the Moon and quite close to it on either side. And it's an unstable equilibrium. So if you know what that means, it means you can kind of roll away from it very easily. Just a little nudge and you start going away from it. But it's a rather gentle, unstable equilibrium. The way it works is that you gradually kind of spiral away from it. And you can get these kind of orbits around the Lagrange positions. And typically, you wouldn't try and stick right on it, but you would stick in this orbit around it, where your space station is gradually moving around the Lagrange position. And then it's very easy to do the station keeping there. And then it also turns out there's a very easy trajectory from one to the other. So if you're in the L1 position, then using hardly any rocket fuel at all, you can go all the way around to the other side of the Moon, to the L2 position, and then back again. Just go there and just stay there, and stay there for a while, and then come back again, and you can just move back and forth as you like. Well, if you want to simulate an interplanetary mission, then I suggest a way of doing it, and it's something that people, astronomers, have wanted to do, and mission scientists, and is to set up a station in the L1 and L2 positions. And once you start getting shortwave centrifuge, if it works, then, and if you can start getting closed system habitats that work, then that makes it much more practical to have an L1 and L2 space stations, because you just send your astronaut there for several years at a time, rather than continually shuttling back and forth. And then send all their supplies over, and they make their own oxygen using algae, they grow their own food. And if you can do all these things, if it is possible to do all those things, then we can start doing it there first. It would be a very good place to apply these ideas. And there's an awful lot of interesting stuff you can do studying the Moon. So you can look, studying the surface of the moon for looking for meteorites from the Earth, for one thing, from the early Earth, from the first few 100 million years. There may very well be meteorites of Earth, meteorites on the moon. And this may be our best evidence from those times. And it's possible, especially later on when we know there's life, there may actually be evidence of life on the moon as well. And it's even possible that there are fragments of ammonites and trilobites and things on the moon. And that's not too far-fetched, because at the very edge of when you get a big impact on the Earth, then at the very edge it's only lightly shocked, the material goes into space. And then when it reaches the moon, it's because of lesser gravity, it's not so enormous an impact there either, and no atmosphere for it to burn up in. So there certainly is some possibility of finding some quite interesting stuff on the moon, probably the most interesting stuff buried down a little bit below the surface. And you can be exploring it, you could be exploring the ice at the poles, where a very interesting deposit, which may preserve layer after layer records of the solar system. And then another thing you can do, exploring the caves, and it's just the geology of the moon itself, and not very well understood yet, because we haven't got that much actual material from the surface of the moon, looking for caves. And then there's also the building out radio telescopes and ordinary telescopes on the moon. For the radio telescope, the far side is of special interest. And there the idea is that you could trail wires over the surface of the far side. So eventually, of course, the kind of ball-shaped radio telescopes, maybe in craters or whatever. But first of all, then you could just be trailing wires from one place to another. And that would be like the long-range radio telescopes. You may have seen, for instance, the picture of the one that was used to discover pulsars. Just a whole lot of poles and wires in a field. For Jocelyn Bell Burnell, who discovered the first pulsar. That was the telescope that she was working on. There are problems because of these extreme changes of temperature on the far side, on both sides of the moon, because between day and night. And there's also the idea of a liquid mirror telescope. Again, it would have to not freeze under very cold temperatures. And then there's also the possibility in the poles, if it's okay to construct telescopes there, if it's not so amazingly sensitive that you want to actually study what's there, then it's the coldest place in the inner solar system. It's colder than Pluto, it's cold as Pluto, because it's in permanent shadow. And it would be an ideal place to have a passively cooled, a passively cooled infrared telescope. So anyway, there's a lot of interest in the moon from the point of view of science. Of course, there's also interest again from the point of view of resources for building settlements as well, and what materials there are on the moon. Whether you could usefully get materials there for space mining for the Earth and for the science research settlements. So I think that's, so it would be very much like an interplanetary mission, that you would go to the far side of the moon, and when you're on the far side, you would be shut off from the Earth, because you would have, all you would ever see when you're in the L2 position, all you would ever see is the moon. You would never see the Earth. And you wouldn't have direct radio contact with the Earth, so there would be a certain amount of radio isolation as well. You would have radio contact via relay satellites or relay radio stations on the surface of the moon. So it would be quite a bit of the feeling of an interplanetary space flight. And it would be very interesting to see how people work out whether they manage in these conditions. So I think that was all I was going to say. And not to be too surprised if the first test interplanetary spaceflight just doesn't work, and there's some issue that crops up after a year, because that's the very reason why you do it. That's why you do it close to Earth first. I very strongly feel that we should do it close to Earth first, even, no matter how exciting the rest of the solar system is. I don't think we should send multiple year missions to Mars or to Mercury or to Jupiter or whatever until we've done at least the same length missions, and the ideal place to send them is to the far side of the moon, and again to the near side of the moon as well. So just my suggestion. Leave it at that. I'm going to be talking on the space show on the 14th of March, and that's part of the reason I've started giving these video talks on YouTube in preparation for it, getting used to talking about these ideas. It's quite surprising that there's a great tendency to go, yeah, haha, like that, and big interruptions while you're talking. And I was more susceptible to that than most people, I think. If you'd seen as I was before I tried doing these video chats, at the very beginning, it was really, it's a little bit hard to make out what I was saying. You can't follow the drift of it because of all the interruptions. And also often coming out with the wrong word. So this is partly also for exercise, because I've done a lot of writing about these things, but I'm not very experienced in actually talking about them. So that's why I've started making these video talks. And this, I will very probably write this up as another one of my Science 20 articles, and it's similar with the other two I did recently.